Steel. Steel for strength and tremendous driving power. Steel for durability. Steel for safety. Plus, all the built-in values that modern machines, controlled quality manufacture, human skill and experience can give us. This is the seamless tube. There is hardly a human need which seamless steel tube does not touch in one way or another. In serving the public in 1,000 different pieces of modern equipment in homes, factories, and towering office buildings. In transmitting power to the throbbing dynamos of our nation's industries. In assuring an uninterrupted flow of ground transportation between the nation's borders. In furnishing the food and fiber for millions of people as an important part of a vast variety of farm machinery. In safeguarding the lives of passengers on global airlines. In assuring peak efficiency for every car on the highways of America. Every tank in Uncle Sam's Army. And deep in the great ships that plow the waterways of the world. Yes, in 1,000 ways, modern living and commerce depend upon precise economical production of seamless tubing. Here at South Lyon, Michigan, this precision art of production has reached the highest degree of specialization. For over a quarter of a century, the Michigan Seamless Tube Company has been meeting the most urgent demands in war and in peace for highest quality products and dependable service. Here, highly trained technicians act quickly and accurately in developing the proper tubing to meet the exacting specialized needs of modern industry, homes, and factories. Tubing, tailor-made to meet your individual requirements. Here, skilled craftsmen, using selected raw materials, modern rolling and finishing equipment, guard and control the production of seamless tubing to make it ready for whatever service it may perform, to make certain the customer receives what he needs when he needs it, on time. Yes, with every order, the customer is given a specific date on which his material is to be shipped to him. This means that his labor and production schedules can be planned ahead on a positive basis. Let's follow the progress of some of these orders to see how this promise is kept. Perhaps the greatest single factor in the production of quality tubes is the steel from which they are made. Michigan Seamless Tubing uses only the best grade from mills which have proved their excellence in making the best grade of steel in the particular analysis required and for the specific customer use. Not only is each shipment certified by the supplier, but a double check is made at the mill to verify each lot. Samples are taken at random from each shipment and sent to the metallurgical laboratory for testing before the steel is released for production. This is the first step in the control of quality in a long line of many such steps throughout the production of Michigan Seamless Tubing. Once the steel has been okayed by the lab, the steel rounds are moved into the mill and cut into lengths called billets. The diameter and length of the billet is determined by the size and wall thickness of the finished tubing. The cold billets are automatically charged into the furnace, evenly spaced on a specially designed hearth, which allows even heating from end to end as the hearth slowly rotates. Temperature is carefully controlled according to the chemical analysis of the steel, and a recording is made of each heat. The billets move slowly through increasingly hotter zones until they reach the exact uniform temperature for the important piercing operation to follow. The hot billets are taken out of the furnace and rushed to the piercing mill, where they are forced into contact with the piercing rolls. This is the heart of the seamless process. The two piercing rolls rotate in such a manner as to advance the hot billet through the piercing mill by applying pressure on opposite sides. This forging action opens up a hole in the center of the billet and draws it over the piercing point. Here's the way it works. The pass is a combination of two power-driven barrel-shaped rolls. This is the piercing point, and it is supported on the forward end of the piercing bar. The bar rotates freely, but is locked in place so it cannot move backward. Here comes the heated billet to be pierced. When the billet is pushed into the piercing mill, the rolls take hold of it and rotate it over the piercer point. The powerful action of the rolls causes the steel to flow through the mill and over the piercing point. As the whirling hot billet moves forward, the displacement and working of the steel is a true forging action in which the hot steel flows over the piercing point. At the same time, as the rolls are forging the steel, upper and lower guides control the diameter of the pierced tube. The piercing operation takes only a few seconds, and the fiery pierced billet is now the rough beginning of a tube that has undergone one of the most rigorous tests imaginable. The tube is never still. While still at forging temperature, the rough steel shell moves on to the high mill, where one of the most dramatic operations in the entire production of a seamless tubing takes place. Here, the highest skill is required of men in the job of catching the red-hot steel tube as it comes roaring from the mill, sending it back again and again. Each time, a forging action takes place as the tube passes between the water-cooled grooves of revolving rolls. Each pass reduces the diameter and wall thickness of the tube, refines both inside and outside surfaces, and increases the length. And with each pass, the operator checks to make sure that the material is doing exactly what it's expected to do. The high mill is a typical example of how control of quality is maintained every step of the way because of men. Here, flexibility of operation, not possible with machines, is the keynote. It means better control, better inspection, quicker changes from one order to another. Small orders need not wait for grouping, but can be worked in on any schedule with the same certainty of punctual delivery. All Michigan seamless products are further processed after the hot mill operations, either by cold drawing or by tube reducing and cold drawing. To prepare the tubes for cold drawing, first, the tube must be pointed. Next, it's pickled in a mild solution of sulfuric acid and water to remove the scale. This operation is necessary to allow cold drawing. An inhibitor in the pickling bath controls the acid action so the steel is not attacked. This is the way the tube looks after pickling, completely free of all scale. And now we come to a parting of the ways, so to speak, because low-carbon steel tubes are soft enough for cold drawing. The steel in high-carbon and alloy tubes is too hard to be workable in the hot-rolled condition and must be softened by annealing. Some steels can be successfully annealed in the continuous type controlled atmosphere furnaces. Tubes progress slowly through heating, soaking, normalizing, and cooling zones in carefully controlled atmospheres. Atmospheres which allow anneals without scaling and even prevent loss of surface carbon on aircraft and similar alloys. It's this precision control that greatly reduces the amount of scale usually formed during annealing, another factor contributing to high quality. Some steels requiring special structures are annealed in this revolutionary new furnace, unique among producers of seamless steel tubing. This furnace makes it possible to program anneal any type of low alloy and carbon tubing to obtain any structure possible with a particular grade of steel. The fact that these structures can be obtained in scale-free atmosphere is an outstanding development in the industry and a Michigan seamless first. This high nitrogen gas generator supplies the atmosphere for the new batch-type furnace and any one of the continuous annealing furnaces. Use of this atmosphere allows control of carbon on aircraft and similar alloys through all annealing operations, another Michigan seamless first. The result is the highest quality and strongest tubing which can be made. After annealing, all tubes for cold processing must again be carefully pickled in acid, rinsed, treated chemically by special process, and dipped into special lubricants. This also applies to low-carbon tubes, which are not annealed prior to drawing. These operations are of utmost importance for all cold processing work, and Michigan Seamless has developed these practices to the utmost under direct laboratory supervision and control. Tubes are now ready for cold drawing or tube reducing. The equipment for cold drawing seamless tubing consists of powerful draw benches. Each draw bench has a die positioned in the center through which the tube is drawn. A hardened chromium-plated steel or tungsten carbide mandrel is placed inside the tube from the opposite end. The tube enters the die with its pointed end projecting through the die opening. The pointed end of the tube is grasped by the jaws of the drawing pliers. Power is applied with a pull of up to 100,000 pounds, and the tube is drawn. The steel actually flows cold through the opening between die and mandrel. Here's just what happens to the tube when it is drawn through the die. The pointed end of the tube to be drawn is inserted through the die. A rod holds the mandrel even with the die while the tube is being drawn. The grips of the drawing pliers grasp the pointed end of the tube. The force of the pull displaces the steel in the tube, reducing the diameter, the thickness of the wall, and increases the length. As many as 12 passes through dies of diminishing diameters may be required to obtain specified finish dimensions. This operation stresses the steel beyond the yield point, and it flows cold through dies and over mandrels. In every operation, the operators are responsible for the quality of work and of the tubing produced. For further control of the quality, Michigan Seamless uses trained gaugers to check for all quality factors on every cold draw pass. Since the cold drawing process stresses the steel beyond the yield point, only full-strength, high-quality tubing can be successfully drawn. This process causes severe work hardening, and in general, tubes must be annealed between passes. Such anneals are followed by the complete pickling and lubricating practice we saw before. A supplementary method of cold production of seamless steel tubing is the tube reducing method. In this machine, semicircular dies containing tapering grooves rock back and forth, while the tube is alternately advanced and rotated over the long tapering mandrel. The dies perform the rocking action under very heavy pressure, which causes a large reduction in the diameter and wall thickness of the tube. Seamless tubes reduced by the tube reducer method may be shipped as finished product, but at Michigan Seamless, they are usually further processed by cold drawing to obtain the desired finish, size, and physical requirements. Tube reducing allows better control of concentricity and greater work hardness, and the combined tube reducing cold drawing process allows the best control of quality, greater flexibility of size, wall, and strength, and produces the best all-around quality of any known process. After final tube reducing or cold drawing, tubes may be given a final anneal or may be finished without further annealing. So far, all the tubes we've seen have been round, but many specifications call for seamless tubing in a wide variety of special shapes, such as square, rectangular, oval, octagonal, and streamlined. For the most part, these shapes are formed between the rolls of the Turk's head. At Michigan Seamless, all such shapes are formed over a mandrel for closer control of inside and corner dimensions. Oval or streamlined tubes are also formed from round tubes by rolls that have been machined to produce the desired shapes. Odd and special shapes, such as hexagonal or triangular, are formed by giving the round tube another cold draw between dies and mandrels of the desired shapes. After tubes have been made to final dimensions with desired physical properties, they are straightened. The very modern machine pictured is a 6-roll straightener. Size, outside surface, and straightness are checked by the operator at the start of each load. Shaped tubes go through the gag press, where the operator skillfully manipulates and turns the tube between power-driven dies. Next, the tubes are cut to specified length and deburred. Short lengths are cut on automatic cutoffs, while long lengths and small orders are cut on the manual cutoff. All cut tubes are deburred. The tubes move on. Final inspection. Throughout the entire process of converting solid steel billet into cold-drawn seamless tubing, repeated checks and inspections have been made to detect any flaws or signs of failure. Regardless of this fact, a series of final inspections is still made to make sure every tube meets the original specifications. The outside surface of each tube is carefully checked, as is the inside surface, to make sure the tubes meet specifications and customers' requirements. The uniformity of wall thickness is checked with micrometers and snap gauges. Micrometer readings are made of the outside diameter along the full length of the tube. Only those tubes which meet every single specification can pass. Tests throughout the manufacturing process safeguard the quality of the finished tubing. Just as all steel requires laboratory approval before being released for production, each order of finished tubes must be approved by the metallurgical laboratory before being shipped. No compromise is made with high quality. Here, day in and day out, samples of tubes are pulled apart in this special machine capable of 160,000 pounds pull. There it goes. This test reveals a number of factors of value to designing engineers. What they know about this steel shows up in the sky lanes of America. And this tube is crushed to prove it can take it. Yes, it can take it. 90,000 pounds of pressure with no sign of failure. Here's another, the flattening test. Will it meet the specifications required in the order? Down, down, and still no cracks or sign of failure. Here, the flare test provides a good check for tubing which is to be used as pressure or condenser tubes. A cone-shaped flaring tool is forced into one end of the tube at thousands of pounds pressure. On examination, this expanded or flared end of the tube must show no signs of breaks or failures. A final check is provided by the flange test. The flared tube is upended and additional pressure is applied. Only the best can withstand this test. All tubing, which will be used for conveying fluids or gases under pressure, must pass the rugged hydrostatic test. Locked into position at each end, a number of tubes are tested at the same time along their entire length. Oil, under tremendous pressure, strains against the walls of the tubes. This pressure is far in excess of the internal working pressure the tube is called upon to withstand in actual use. It is interesting to note that no water is used for hydrostatic testing. Yes, this is one more way that Michigan seamless tubing proves it will give safe performance in any kind of service. Certain uses of cold-drawn seamless tube require that they be polished. Here, the outside surface is polished by a rapidly moving abrasive belt as the tube rotates through the polishing machine. So that seamless aircraft tubes can be identified easily and quickly for the special purposes required, they are stenciled along the complete length with the necessary information. Another example of the perfecting touch, symbolizing the care taken every step of the way. The same care that marks every step in the production of seamless steel tubing is applied in preparing the tubes for delivery, packing them for shipping. Particular precautions are taken against rusting by giving the entire surface of the tube, inside and outside, a coating of special oil. When specified, tubes are colored at the ends for quick identification and selection at their destination. Every tube is individually measured and the length reported to a clerk for recording on the tally. Individual packing requirements of each customer receive special attention. Light-walled and other special products are boxed. Others are bundled, baled, or shipped loose as indicated by specification or customer's request. All tubes, whether packed or bundled, are weighed for shipment. And waiting trucks and freight cars are loaded. A special feature of Michigan Seamless customer service is same-day truck delivery within a radius of 50 miles and overnight delivery within a radius of 300 miles. The truck moves out. Another load of Michigan Seamless steel tubing on its way, on time, as promised. Another load of seamless steel tubing rushing to meet the hunger of a nation's need, ready to perform 1,000 useful services in the drama of modern work and living. Yes, from inquiry to delivery, from 17 sales offices conveniently located across the nation, Michigan Seamless Tube Company serves the needs of its customers quickly and accurately, working with them, producing for them, constantly demonstrating its ability to meet the most exacting specifications for the finest in cold-drawn seamless steel tubing, and its dependability in living up to agreed-upon delivery schedules. The finest in steel, the finest in men and machines, the finest of processes. All of these spell out a product of quality and serviceability, of which Michigan Seamless is proud. A product designed to serve the nation best.